Left on their own inside of an atmosphere, all springs will eventually stop oscillating due to air resistance. So when designing a machine that needs a spring kept in motion, you need to provide the spring with a driving force. A driving force usually comes from an external motor or interactions with the environment. The driving force has the job of pumping energy into the spring system to replenish the energy that the drag force takes away. Most driving forces are designed to repeat based on a cosine or sine function and have two important features. First is the amplitude of the driving force. This is the strongest value that the driving force will take on, both in the positive and negative directions. Second is the period of the driving force. The period is the amount of time over which the driving force will repeat itself. So a high value for the period means the driving force will repeat itself slowly, and a low value for the period means the driving force will repeat itself quickly. The 2 pi in the cosine translates this period into the cycles of a cosine curve. Here we have the same code we used in episode 20, but this time we've included the driving force in the total force. We can adjust the amplitude and the period of the driving force by changing these two numbers. Keep in mind this value of 10 for the period while we watch the animation. The graph for this driven damped spring is very interesting. We start out with the oscillations dying due to the air resistance, but then they start to grow back thanks to the driving force. It takes many oscillations for the block to reach a regular pattern, but eventually the spring oscillates with the same period of 10 that we used in the driving force. If we change this period to 15, the final period of the oscillations also changes to 15. This means that the driving force eventually wins out over the air resistance, and that we can control the oscillations of a spring just with a driving force. In addition, if we change the amplitude of the driving force, we see a corresponding change in the amplitude of the spring's oscillations. In case you were wondering, there really isn't much of a difference if we change the cosine function to a sine. There are small changes to the beginning of the graph, but the long-term behavior is the same. So the important features of a driving force are the amplitude and period, which control the amplitude and period of the spring's oscillations in the long term. You have now learned how to study the impact of a driving force on a spring with air resistance. Click on the link in the description below to complete a set of activities to help you further explore this behavior.